Okay. Assalamualaikum warahmatullahi taala wabarakatuh, and a very good morning. Uh, Welcome to my class. This is I think our kuliah yang seterusnya hasil sambungan daripada kuliah yang sebelum ini. For this lecture, basically I'm going to discuss and explain of a new chapter. This is the last chapter eventually. We've entitled belt and rope drive. Yeah. So lebih it more focus on how to calculate the torque of a belt that been driven by the drive shaft lah. Yeah. So this one is a what you call that? This one is the a slide that I got from the internet, but basically it not being very different to the syllabus. Okay. So I shall start my class now, yeah. So for introduction, as we know, the belt or ropes are used to transmit the power from one shaft to another by means of pulley, which rotate the same speed of a different speed. Yeah. So basically, let me show you. Just for information who don't know, this is the belt. Okay. This is the shaft, and this is motor, and this is housing. Okay. So the belt, I need to change color to make it clear. All right. So the belt or rope that used to transmit power from one shaft to another. So what your point of interest? What is the point of your interest? Basically, you want to calculate the belt. The belt performance. This one, the belt performance. Yeah, performance. Yeah, on how it perform or on what the capacity of the belt that can that been drive by the shaft. The shaft here, or maybe the shaft here. Basically, the shaft here going to rotate either clockwise or anti-clockwise, N or RPM lah. Okay. So when this shaft is rotating, it going to drive the belt, and then it going to at the same time subsequently it going to drive another shaft here as well. Okay. So this is the basic idea of the belt or rope that used to transmit power from one shaft to another. Okay. So eventually from there, we in our syllabus, mostly we going to learn about the type of belts. Yeah. What is a type of belt? So for example, we got flat belt. Okay, this is mostly used in the factory and workshop where the moderate amount of power is to be transmitted from one pulley to another, when the two pulleys are not more than 8 meters apart. So this is some sort of like specification for this kind of flat belt type. Yeah, means that the two pulley are not more than 8 meters apart. So these two things, is less than 8 meter. Okay, so that is the condition. Okay, and then what is the flat type belt? This is the flat type belt. Yeah. So this is the flat type belt, and this is supposedly your pulley. This one is your pulley or shaft. Okay. Okay. For number 2, we got V belt. V belt is mostly used in factories and workshops where a moderate amount of power is to be transmitted, from one pulley to another when the two pulleys are not very near to each other. So this one, it can be, it can be far lah. I mean, these two pulley can be far because clearly stated that when the two pulleys are very near to each other. Uh, so if I may rephrase, when these two pulley are very near to each other, then the V belt is somehow um, a very good thing to use lah. Okay. So this is the V belt. Yeah. And then you know lah where's the pulley and so on. Okay. Number 3 is a circular belt or rope. Is mostly used in the factories or workshop. Okay. So same goes here is the application and here's the application as well. Okay. A great amount of power is being transmitted from one pulley to another, and then two pulleys more than 8 meters apart. So here, it stated that it can be more than 8 meter. If it more than 8 meters, then you can use circular belt. If it less than 8 meters, maybe you can use a flat belt or V belt. In fact, V belt is much more near to each other. So maybe it less than 8 meters, right? So that's a thing. So we're going to discuss more in details about the type of flat belt drive, yeah? The power from one pulley to another may be transmitted by any of the following type of belt drives, yeah? Open belt drive, the open belt drive as shown in figure 1. This is figure 1, as shown in figure 1, is used with shaft arranged parallel and rotating at the same direction. The tension is tight side is more than tension in slack side. Okay. So here is parallel. Parallel positions. Yeah. It sits side by side. Okay. Of course, at the top is a bit slack and at the bottom is slightly tight. So slack ni maksudnya dia sedikit longgar. Yeah. Of course, pusingan dia ke bawah dan pusingan dia beginilah, dia pusing cuma di belah atas tu dia a bit slack at the top of the belt is a bit slack while at the bottom is a bit tight. Ni boleh juga awak rujuk dengan tayar belt motor, timing chain motor, samalah ni. Okay. Ini this one is maybe front or side view. While this gambar di bawah ni, the bottom one is the top view lah. Okay. Then we go by number 2. Number 2 is a cross or twist belt drive. The cross or twist belt drive, as shown in figure 2, is used with shaft arranged parallel. When the shaft is arranged parallel, okay, and rotating in opposite direction. What does it mean by that? It's still parallel, still side by side, no problem. However, the rotation is quite different. You know, if you can see clearly here, the rotation is mostly following the clockwise angle. You know, following the clockwise lah. While at this, for this case, yeah, for the cross or twist belt drive, the rotation is for belt. No, for pulley A, it follow the clockwise, while the pulley B it follows anti-clockwise. So this is sort of arrangement where this flat type kind of belt can be arranged, you know, to serve the purpose of the application. Yeah. So here it clearly stated that in order to avoid the wear in the belt intersection, yeah, the shaft should be placed at a maximum distance of 2b, where 2b is the width of belt and the speed of belt should be less than 15 meter per second. So clearly stated here that b is the width of the belt, kelebaran dia. And of course, the speed need to be less than 15 meter per second. This is sort of like two condition. Yeah, this is condition number 1, and this is condition number 2. Should be less than. By having this sort of condition, then you can minimal. You can minimal the wear of the back intersection. Okay. So now I move along. Yeah. This one is a quarter turn belt drive. The quarter turn belt drive, also known as the right angle belt drive, as shown in figure 3. It used with shaft arranged at the right angle and rotating in the one different definite direction. Okay. So we'll see what means by this. This is quarter turn drive, yeah. And this one, quarter turn drive. Oh, my bad. Okay. So you got a driver here, move along in anti-clockwise. When it pull in the anti-clockwise direction, so or maybe the driver is, when the shaft is driven, following the clockwise, so it managed to move the driver, or maybe the driver at this point, the driver move in anti-clockwise, so it can driven this shaft following the clockwise. Yeah, if you can imagine. Okay, so just imagine that you got a driver pushing di sini, and then you got a shaft here pushing. So ni pusing, then dia boleh pusing lagi ni. That is quarter turn belt drive. Alright. Okay, then we go to belt drive with either pulley, belt drive with pulley lah. Basically pulley, it doesn't make a position lah. It doesn't move. It just stays stagnant there. So belt drive with a interpulley, as shown in figure 4, is used with shaft arranged parallel, and when on open belt drive cannot be used to small angle of contact on a smaller pulley. This type of drive is provided to obtain high velocity ratio, and when the required belt tension cannot be obtained by another means. Okay. So more or less it's stated here, like this type of drive provide high velocity ratio, number 1, and when the required belt tension cannot be obtained by another means, something like that lah. Okay, clearly for the application, you got pulley here, and then maybe this one is a driver, this one is what being driven. Okay, so it rotates, anti-clockwise. Of course, it rotates also anti-clockwise. Same with the first one. However, you got pulley here just to what you call that, the function of this pulley. Just imagine if you put it much more higher, and then of course the belt be more tighter. Jadi lebih ketat lah kalau kita naikkan ni ke atas. Kalau kita kurangkan ketegangan dia, then we're going to put this one a bit downward. So I padam dulu. So this one is adjustable, from top to down. Okay. So that's the thing. So I move along. This is another thing. We call it compound belt drive. Okay. A compound belt drive, as shown in figure 5, is used when the power transmitted from one shaft to another through a number of pulley. So you got number of pulley, so we're going to transmit the power from one shaft to another shaft. Okay. So this one is called compound belt drive. All right. Number 6 basically is a step or cone pulley drive. Okay, a step or cone pulley drive, as shown in figure 6, is used for changing the speed of drive shaft, while the main of driving shaft runs at constant speed. This is accomplished by shifting the belt from one part of the steps to other. Okay, we see what is figure 6 mostly. Here. Okay, same goes macam you punya bicycle before this kan. Kalau you ada bicycle, basically this one is attached to the motor. You got motor here, and then maybe it rotates in this direction. So if you want to increase the power, the ratio, macam gear, you want to increase the power ratio or whatever, then you can move this the shaft maybe move, or mostly the shaft going to move from the left to the right, from the much more larger pulley to the smallest larger pulley, a small pulley. Then you're going to have a ratio. From there you can adjust the speed of the drive itself. So it's going to be either this part moving along side by side. Same goes with this one as well, it moving along side by side. Okay, and maybe lastly, from if we can discuss a typical type of belt. Here we got fast and loose pulley drive. A fast and loose pulley drive, as shown in figure 7, is used when driven or machine shaft is to be started or stopped. Whenever desired, without interfering with the driving shaft. A pulley which is keyed to be the machine shaft is just called fast pulley. And run in the same speed as that of machine shaft. A loose pulley runs freely over the machine shaft and is incapable of transmitting any power. When the drive shaft is required to be stopped, the belt is pushed on the loose pulley by means of sliding bar, having belt forks. What I mean by that? Let's see. So here is a fast and loose pulley drive. We got machine shaft. This is fast pulley and this is loose pulley. Okay. What I'm trying to say here is a loose pulley runs freely over the machine shaft. Right? The loose pulley runs freely over the machine shaft and is incapable of transmitting any power. Okay, when the drive shaft is required to be stopped, the belt is pushed to the loose pulley by means sliding bar. So basically, it's kind of like when you want to stop the belt, you're going to exchange. I think you're going to exchange this sort of like machine shaft. You're going to move it side by side. You're going to have, let's say you want to have a fast pulley, you're going to change to the fast pulley. If you want to stop, then you change it to loose pulley. So you got kind of like options, throughout your system or mechanism. Yeah. So mostly fast pulley, if you change it to fast pulley, then it can follow. It can parallel workout. It can be as equivalent to the driving pulley sort of speed. However, when you change it to loose pulley, and then since loose pulley is just run freely over, so it doesn't transmit any power at all. Dia macam keadaan ni kalau biasa bawa kereta manual, dia ada clutch. If you put clutch, if you press your clutch, what happen after? Even though you are in gear shift, still it doesn't transmit any power at all. Yeah, it doesn't transmit power at all. Yeah. So that's the thing. So that's all from me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.